ShareSat, and today I'm going to be talking about how the different categories were created. So, I think it is very interesting, and there are three ways that the periodic table is organized: by groups, blocks, and periods. So here are the blocks. We have the S block down here on the left, the D block in the center over here, the P block over here, some unknown and gray elements, and then we have down here we have the F block, and so I think this organization is a little complicated, so I organize it the way I like to, which is by groups. So here are the groups. You have the alkali metals, not considering hydrogen, the alkaline earth metals, and then the transition metals, the poor metals, the metalloids, the non-metals, and by the way, hydrogen's a non-metal, and then halogens, the noble gases, and here are the lanthanoids and actinoids. The lanthanoids over here, the actinoids over here. The lanthanoids and actinoids together I call the rare earth metals. So, the way that the categories are created are by the elements valence, electrons, and orbitals. But before we go on, I have to show you what we mean by that. So I drew bromine over here. So bromine has an atomic number 35, which means it has 35 neutrons, the green one, 35 protons, the pink one, and 35 electrons, the blue one. Except for hydrogen, every element has 2 electrons in its inner shell. As you can see here, those are the 2 electrons. And then its second shell, it has 8 electrons, and it has 18 in its third. Bromine has 7 electrons in its outer shell, and the electrons on the outer shell are called the valence electrons, and these 7 valence electrons make this a halogen. And as you can see here are the halogens, and here is bromine. So I'm going to talk about the alkaline metals. So these are the alkaline metals, but not considering hydrogen. So they have all of the alkaline metals have similar properties, and those properties are that they are all reactive, they're soft, and then when you cut them, they are very shiny, and then they lose their outer electron to become a cation to positive 1 charge, and then they have an s orbital. So, Sophie, go ahead.
An example of the alkaline metal is sodium. Sodium symbol is Na with an atomic number of 11. It is very cool because it is found in everyday salt.
Okay, so let's move on to the next group, the alkaline earth metals. Okay, so the alkaline earth metals are actually pretty similar to the alkaline metals. They're all reactive, they lose their outer electron to become positive 2 charge, and then they are shiny, and they have an s orbital. And did you know that all alkaline earth metals are in nature? Okay, Sophie, let's move on. Go ahead.
Examples of the alkaline earth metals are calcium. I like calcium because, by the way, actually, the calcium symbol is Ca with an atomic number of 20. I like calcium because it is found in our bones.
Okay, so let's move on to the next group. Here are the transition metals, and it's the group with the most elements, and they're in the D block. The transition metals have 2 elements that are really interesting. One of them is also known as the filament of light, and it has the highest boiling point, which is why it's a filament of light. And this element is called tungsten.
Tungsten symbol is W over here, 74. With an atomic number of 74. It is not that reactive.
Okay, and then another interesting transition metal is iron over here. Iron exists in one of the most exothermic reactions. This is called
the thermite reaction.
And a thermite is a compound made of aluminum powder and iron oxide. Mix the compound, put it in something, put a metal rod in it, and light the rod on fire. The fire creates a chain reaction and goes down the rod. And then it starts burning, and then the compound starts burning, and the two chemicals start battling for the oxygen. And at the end of the experiment, the aluminum has the oxygen, and we have aluminum oxide and molten iron. So that's the experiment, and we can show show you videos of this experiment on our YouTube channel. And yeah, so iron's over here, and then and did you know that a thermite reaction is so hot it can go up to 5,400 something 5,400 something degrees Fahrenheit, which is like so hot. Okay, so Sophie, can you tell us about iron?
Iron symbol is Fe with an atomic number of 26. It is one of my favorite elements.
Okay, so let's move on. We're at the poor metals, and the poor metals are the first group in the P block, and they are known for their poisonous elements, including thallium and where's antimony? Oh, thallium and antimony. Actually, antimony is not part of the poor metals, but it is pretty poisonous. But thallium is actually the most poisonous poor metal. Oh.
So two examples of the poor metals are aluminum and thallium. Aluminum symbol is Al over here with an atomic number of 13 over here. So, just like iron, it is in the thermite reaction.
And that's
so,
thallium.
Thallium
over here.
symbol is Tl here. Atomic number is 81.
Okay.
Just like Alex said, it is one of the most poisonous poor metals. But I think he meant to say it is one of the most poisonous poor metals that is not radioactive.
Actually, she's right. Thallium is not the most poisonous poor metal. That's actually polonium because it's radioactive. Oh my gosh, actually, okay, never mind. Polonium is part of the poor metals, but over here, astatine is supposed to be a metalloid. But anyway, let's move on to the next group. We're at the non-metals, our favorite group because it has our favorite elements. And those elements are elements that we could not live without. Okay, and by the way, the non-metals are in the P block. So if you give us some examples of the non-metals.
That is carbon, nitrogen, and oxygen. Carbon symbol is C with an atomic number of 6. Nitrogen symbol is N with an atomic number of 7. Oxygen symbol is 8 with an atomic number of, oxygen, oh my god. Oxygen symbol is O with an atomic number of 8.
Okay, so here, and did you know that 65% of our body is oxygen, while only 18% is carbon? But carbon is still important because it's found in all 4 organic groups. And those 4 organic groups are called proteins, nucleic acids, lipids, and carbohydrates. Okay, we're moving on to the next group, the halogens. The halogens actually are part of the nonmetals, but most scientists consider it separate from nonmetals. Okay, so the halogens are also in the P block, and they have only 5 molecules, but they still have elements in all 3 states of matter. And can you name those, Sophie?
Liquids, gases, and solids. An example of a liquid is bromine.
Over here.
Over here, and he drew a picture of that.
Yeah,
here.
over here.
And an example of the gases is chlorine.
Over here.
Over here. And an example of a solid, which is my favorite element. Number 1 is iodine. Over here.
Yep, it's over here.
By the way, iodine symbol is I with an atomic number of 53.
And then it's her favorite because it can be a solid and gas in room temperature. Yeah? Right, Sophie?
Right.
Okay, and I also wanted to say a couple words about fluorine. It is the most reactive element in the periodic table. It reacts with every element except helium and neon. And then I know some reactions with it, platinum hexafluoride reacts with platinum to create platinum hexafluoride, and then it reacts with krypton. I forgot what it was called, I think. and it reacts with sulfur to create sulfur hexafluoride.
By the way, krypton is over here.
Yeah, and then fluorine is way up here. And it's over here because it's like the top right. It's so reactive because it's the top right of the periodic table. But anyway, I'm going to move on to the next group over here, which is the noble gases. And all noble gases are monoatomic, and they are inert. And they are inert because their valence shell is full, so they don't want to give any electrons, and they don't want to get electrons. And so, Sophie, can you give us some examples?
An example of the noble gases, which is over here,
And over
is
here.
radon. So, radon is one of the most radioactive noble gas.
Yeah.
And another one is helium. By the way, radon symbol is Rn with an atomic number of 86, while helium symbol is He with an atomic number of 2.
So the next two groups I'll talk about together, and those are the lanthanides and actinides, and those two groups together are called the rare earth metals. And this is the first group in the F block. So the lanthanides. Some people think that all but one of the lanthanides are in the F block. Others think that even promethium is part of the F block. And then, but that's not important. What's important is actually that all lanthanides are not radioactive except for promethium over here. And then the actinides are actually the exact opposite. All of them are radioactive. And an example of an actinide is uranium. Did you know uranium is actually the only radioactive element that has an isotope that is not radioactive? Okay, go ahead.
So, today I'm going to talk about the lanthanides and actinides. So, this lanthanide I'm going to talk about promethium. And the actinide I'm going to talk about uranium. So, promethium symbol is Pm with an atomic number of 61, which is over here.
Yeah, okay, so this is promethium, and then here is uranium.
So, do you know that? So, another actinide is uranium.
Here it is.
Uranium symbol is U with an atomic number of 92.
And those rhyme. U92. Okay. So and then a few months ago, two elements were discovered: flavorium and livermorium. And it doesn't say flavorium and livermorium here because this was made before flavorium and livermorium was discovered. But anyway, flavorium symbol is Fl with an atomic number of 114, as you see here. And then livermorium symbol is Lv with an atomic number of 116.
I love to say flavorium and livermorium. So,
livermorium. Okay, and then finally,
now we will end the show with a joke. Two atoms walked into a party. At the end of the party, one atom walked to another atom. The atom said, "I lost an electron!" The other said,
"Are you positive?" That's so funny. And it's funny because when you lose an electron, you become positive. So it's a play on words.
So this is the end of the show. So thank you for listening to our show. And on